Do you see that? Is it allowing you to record now?
Mm-hmm. Yeah, now it says recording.
Okay, super. All right. So today we'll just go without video, and I'll work on a spreadsheet and PowerPoint. So you'll kind of see so I don't think it'll be that big of a deal other than I took a shower. I do look nice. I've got a suit on and everything, and you guys can't see me, but we'll roll with it. And so let me get set up here, and I'm going to share my screen so that you can see everything that I have. Okay, so you guys starting to see stuff pop up?
Mm-hmm.
Yes.
Yes.
Great. And let me get into your class. Not sure what happened to my video camera. I have no idea. But we're going to be working in chapter 6 still. And let me tell you, Alvin, and it's going to take a little bit of time after we end class to convert, and it automatically does it for you. It'll convert the video, and then what you'll have to do you know how to put it up onto YouTube?
I do not.
Does anybody else know how to use YouTube easily to post videos? No?
Do I need to have a
You guys are
YouTube
supposed
account?
to be young millennials. Yeah, you'll have to get a YouTube account, and then it's real easy to upload. You just add the video, and you're going to get, like, once it's done converting, what it does is it gives you 4 files. At least that's what it did for me. It gave me 4 possibilities of files. One was just audio. The other 3, I'm not sure. I know one was audio and video. And so you'll want to pick the one in which is the best, which is the audio and video together. And it will be on your hard drive. It put mine under Documents and Zoom. So it's got a folder under your documents called Zoom, and it'll have 3 or 4 probably pretty large files. And all you do then is go to YouTube, set up your account, and then you can upload a video from that. And I learned to upload a video via just Googling it. It's pretty simple. And it depends, like on mine, I just drag the file over, and it's got a big plus sign, and you can just drop it into YouTube, and it will take a little bit of time to upload it. But then once you upload it, then you'll have a link, and you can send me the link, and I can post it for everybody onto Moodle so everybody has it. Any questions? And that way it will not screw up the next class and their ability to get a video. So I'll just assign you to do that for me every time so that everybody has it. Okay, so we're gonna get into multiple cash flows, and let's see, this is chapter 6. And I'm not going to be able to do the math for you on the board like I did last class period because of the video issue. But we'll do everything in Excel, and I suspect that's what you guys will do anyway when you work on this in class for a test. And let me get a good spreadsheet up here, and you don't have to look at my upper level class. I'll get a clean one up for you guys. And I'm going to share. And I think it's best to share the whole screen. Can you guys see both the PowerPoint and the Excel?
Yes.
Yes.
Yes, good. Okay, good. All right, so we've already gone through a good bit of chapter 6 already. We did mixed cash flows. And we did that last class period. And mixed means that they have different values for each one of the multiple cash flows that they offer you. Then if you guys watched the video I posted for you, what I posted was the 330 class. In the 330 class, actually, we did a couple of annuity problems. Actually, we did one annuity problem at the very end. And that's where I'm going to start with you guys, because that's where we left off. But if you watched that video, you would have already seen a little bit of annuity problems. And annuities, there's two different kinds of annuities. One of them is an annuity that is due, and the other is an ordinary annuity. And let's see, this is a retirement problem. And this is an annuity problem. So let's see if I find one that's good. I think this is a good one to start on. So I'm on PowerPoint, which is on chapter 6, page 15. And it says you're offered the opportunity to put some money away for retirement. And it says you will receive 5 annual payments of $25,000, each beginning in 40 years. All right, so actually this is a pretty difficult question to start off on, but this is an annuity question. And I'm going to put this in a table. And I'm going to have time in the first column. And it tells me that we need $25,000, and we need 5 payments of $25,000, but not starting for 40 years. So I'm going to create a table here, in which is going to be 40 time periods long. So it's going to be a long table. Now you can imagine that I would be drawing a timeline just like this on the whiteboard. I'm just going to add the values in here. It says you're going to receive 5 annual payments of $25,000, each beginning in 40 years. So our first payment of $25,000 is going to come in that 40th year, right? So we're going to get 5 of those. So here's 1, 2, 3, 4, 5. All right, so here's important thing, that year 40, that is the end of year 40. All the rest of these time frames here, we have no cash flows. They don't even start until year 40. So that's what our timeline looks like, and I put it in a table form. All right, so it says, how much will you be willing to pay to invest today if you desired an interest rate of 12%? Okay, so we've got an interest rate. Here's our cash flow and our interest rate. And this is an annual interest rate, and I'm putting in 0.12 here. And it's going to be applied to the entire set of cash flows, 12%. All right, and it says, how much would you be willing to be paid today? So they want the value up here at time period 0, right? And so with that, I'm treating this just like we've done every single other problem, and that is to treat it as a mixed cash flow, in which we have to do by hand each one of them separately. This is going to be probably, in this particular case, take us just about the same amount of time as if I did it in one single cell. But one cell is going to be, we're going to be able to do this in 2 cells when I show you the easy way. But when we want to find the present value, same thing as always, we're going to hit equal present value, open up the parentheses, the interest rate is 12%. The number of periods in which we're bringing back each cash flow, this first cash flow, 0, is in time period 0, and we're going to bring it back only 0 times. And there is no payment, and the future value is the cash flow. And you can see there's just going to be a series of zeros all the way down until we get to the bottom here. So I'm going to show you that equation at the very bottom here where those $25,000 payments actually start. You can see the present value taken back to time period 0. We're taking it back to time period 0. How I can tell that is we're bringing it back 40 time periods. So this $25,000 cash flow that I receive in 40 years is going to be brought back into present value terms. And present value here means time period 0. And then we're using a discount rate of 12%. And you can see the second $25,000 cash flow, it's going to be brought back in time by 41 years with an interest rate of 12%. And the cash flow is, again, $25,000. So what these numbers are telling me is that if I had $268.67 today to invest for 40 years, I would actually have $25,000 for year 40. If I had another $239.88 today, I could invest it for 41 years and have $25,000 that I would receive in time period 41. All right. And this last one, I'll skip to it. I've got a present value of, if I had $170.74 today, I would have $25,000 in year 44. All right. So if I just add up these present values, see where my, when I just add them up, sum them up, present value, totaling them all up, if I had $1,084.71 today, I would be able to provide myself with 5 equal payments of $25,000 starting in year 40. That's a little retirement plan for us. That's a really small amount of money, isn't it? So if you only have $1,084.71, and if you can actually get that invested at 12% a year, then you would actually have this, what we call an annuity right here, 5 equal payments of $25,000 apiece, right? All right, so I can do this our old way, which is creating a big table. All right, that's what we've done over and over again. Or I could reproduce this number by hitting equal present value. The rate is 12%. The number of periods. Now, we have to really talk about what number of periods means now. We've got NPER that needs to be associated with not only a future value, but a series of payments. So I've got a series of future values that are $25,000 a piece. That is also called a payment, and I got 5 of them. So if I put in NPR of 5, it's going to tell me to not only, I've got 5 payments of $25,000, and then the future value, I'm going to put in a 0. So how Excel sees that is that it's going to take $25,000 equal payments over the course of 5 years, starting in period 40. All right, so these 5 cash flows, and then it's going to calculate the present value, but it's not going to calculate it at time period 0. It's calculating it at time period 39. Right? So I'm going to hit equal, and you see that value. What we've done is we have converted 5 payments of $25,000 into one single lump sum future value at time period 39. Right? So I'm going to redo a timeline here. Here's time period 0, time period 1, 2, 3, 4, and 5. And you can see here that when you take a present value of this $25,000 one period back, and you add to it the present value of this second $25,000 value 2 periods back, this third one 3 periods back, and then this fourth one 4 periods back to my new timeline here, and then this last one back all the way to our new time period 0, we end up with the value that's actually the present value in time period 39. All right, so I could have written that right up here. Here's the present value, 0.12. Number of periods are 5 payments that are equal of $25,000 a year and no future value. And I get $90,119.41. Now what I need to do though is I don't need our value in time period 39. We need it back at time period 0. So we actually have the case where we can now do a second present value calculation where we have an interest rate now of 12% still, but now we're taking this back 39 years. We have no payment. We have instead a single lump sum, and that's $90,119.41. And we get the same answer. Is there any questions?
Can you highlight that formula again?
This one?
Yes, ma'am.
Yeah. So what I've done is basically taken 5 values that are on a timeline, and this is a very long timeline, but 5 values, I converted them into one value, 90,119. And then I converted that lump sum, and I could convert it back to time period 0 like I just did to show you that it's the same answer as if we did it through a table. Or I could, if you would have told me you wanted to know how much you needed to have in an account by year 10, I could do that instead. So once you have it in a lump sum form, you can move it anywhere on that timeline that you want. How you guys doing? So this is actually starting off with a pretty tough question. And because the way I see this timeline here is that I've got one annuity in which I have zeros. That's an annuity, right? I got 39 zeros. And then I've got another annuity, which are $25,000 a piece for 5 years. So I see 2 annuities here. And I just have to basically figure out how to get Excel to work. All right, I'm going to try another one here. Okay, after carefully going over your budget, you have determined you can afford to pay $632 per month towards a new sports car. Now this is one that I really wish I had the board to show you a timeline with. But $632 per month, that is an annuity. It's a monthly annuity. All right, so you call up your local bank and you find out that the going interest rate is 1% per month. All right, so now they've told you this in monthly terms, not annual. Normally, when you're faced with a contract, they usually give you an APR, an annual percentage rate. Here they're not. I don't know what's going on here. I'm getting way too many emails here, but you're going to have to, here we got 2 complications. One, we have an annuity. It's $632. It's monthly, so that's another complication. So it's going to be monthly the payment's going to be monthly, and you're going to assume monthly compounding. And then you also have an interest rate, which is in monthly terms, and you've got it, your number of periods also in monthly terms. So they've made this question kind of easy on one hand, in a sense that they've given everything to you in monthly terms, which makes it pretty easy to put into Excel. But there's some complications here, and that is you've got monthly compounding, you've got an annuity, and so this is actually a pretty, complicated question, but this is one you would face when you go out looking for a car. So has anybody ever gone out and looked for a car? Anybody done that?
Yes.
Yep. Anybody gone car shopping?
Yes, I have before a little bit.
And when the salesman comes out to you, the first thing they ask you typically is, how much can you afford per month? Have you ever noticed that?
Yes.
Yeah, they want to know how much you can pay monthly, and they want your eye off the sticker price. Sticker prices are pretty high, and it's kind of scary when you look at the sticker price. But what they're doing is converting their sticker price into monthly payments. And that takes your eye off the ball, because then you're not as intent on negotiating with them that way. Does that make sense to everyone? It's like they're basically diverting your attention over to monthly payments instead of the $50,000 sticker price. That's really outrageously high, right? So first of all, if you go up to that salesman and you say, I can afford $632 a month, that's what I can do. And he probably won't even talk to you about the interest rate. And if he does, it wouldn't be surprising that he puts it in monthly terms, because it says here in this problem, the going interest rate's 1% per month. Well, you convert that into an APR, and that's 12% per year. That's pretty high. But when you think 1%, that's not that big of a deal. That's a small number. That's not bad. 1% a month is pretty darn high. Well, let's talk about now, how do we figure out how much they're actually going to lend to us? In other words, how much would this car loan be for? All right, so I'm going to put in here present value, because what we're doing is we're trying to find out what is the value of the loan that you're going to be taking out if you're going to pay $632 a month. Okay, so the rate I'm going to put in here, everything needs to be consistent as far as the term goes. So the payment is in monthly terms. Everything else needs to be in monthly terms, right? So everything has to be consistent. The interest rate has been given to you as 1%, and that is in monthly terms. That is R over M is 1%, right? The number of periods, 48 months, is also in monthly terms. They didn't tell you 4 years, all right? So 4 years and 48 months is the same, but you need to put into Excel 48, because everything has to be consistent. You've got a monthly interest rate, you need a monthly number of periods, and you need a monthly payment. And so I'm going to put in a minus 632 here. The reason why I put in minus was just because I'm taking it from your side. As the car buyer, you're actually going to be paying out $632 a month. All right, there's no future value. This would be where if you had a loan that had a balloon on it, meaning that you don't completely pay off the loan with the payments, that you get a big balloon at the end. And so I'm going to put in 0, or I could just close up the parentheses now. But notice the type. Now that we have a payment, we need to tell it type. It's either type 1 or type 0. And type 0 is what we call an ordinary annuity. And that means that your first payment is due at the end of the first period. If it's a annuity due, that means that your first payment is due at the beginning of a period. That means now. Your first payment would be due at time period 0, right? So most loans are set up as ordinary annuities, type 0. And so you can type it in with a type 0 and close it up, and you'll get the same answer. So it's really close to $24,000 is the amount of money you could borrow. Or you could come in here and you can actually close up the the equation right after the payment, because everything else after it are zeros. And so Excel will recognize that the same as putting a 0 in, as if you just leave it blank. And so your answer to this question is that you will actually be able to borrow just about $24,000. Okay. All right, so it's easier to see a car loan when it's $632 a month than it is when it's $24,000 total. Right? Those are two very different numbers. The small one is a little bit easier to take. But the fact is that they have not only gotten you to pay $24,000 for the car, but they also have gotten you to pay 12% interest. Right? Any questions about
Can you
that?
formula one more time, please?
Now, yeah, no problem. There we go.
And also, could you go back over like the 0 in the formula, that was the ordinary annuity or the annuity due?
Yes. So ordinary is 0 and annuity due is 1. And then I'm going to do this same problem in a chart. So the long way, I would say. So you saw that was one single cell. I got what they would lend to me. It's 24 grand.
Mm. Yeah.
Now, can you guys kind of understand why a car salesman would want you to focus on that payment? The payment's easy to focus on for him because it takes your eye off the interest rate that you're being charged, and it takes your eye also off the large present value, which is the value of the car. And so he wants to keep you on payments and keep your eyes on kind of distracted from the real things that are going to matter as far as the value of the car. They don't want to have to negotiate with you a price that's lower. Now, and it's because that these car companies, they'll have Toyota, for instance, has their own financing arm. They have a finance company held within Toyota. And so if you go to Toyota to buy yourself a car, they are happy oftentimes to lend to you through their financing arm. Does everybody see why they would want to do that? Rather than sending you out to a bank and finding your own loan, number one, you're more likely to be rejected when you go out to that bank. Number two, it takes you off the premise of the car lot, right? And you might not come back if you have to go out and borrow from a bank. And number three, they have control over the interest rate. They have these variables. They have the interest rate they can work with. They have the payment they can work with, and they have the number of periods they can work with. So if you come in and say, oh, I can only afford $632, but I really have
Hello.
they have adjustments there that they can make, in which make it easier for them to deal with getting you into that car. And if instead you get your heart set on that one car and you really can't afford it, and then you're sent away to get a loan at a bank, then all of a sudden, it's possible that you don't get back onto the lot to actually make the deal go through. So there's a real good reason why those car companies have finance companies associated with them. Is there any questions with that? Okay. All right, I'm going to do that same problem, only I'm going to do it with this chart, right? So this chart's going to be a little bit longer. It's going to have very different numbers in it too. Oh, they told us it was 48 months. So I'm going to come out here with 48 months for the time periods. And you're going to pay starting at the end of the first period, which is at the beginning of year one, which is at, it's going to be, I'm going to say negative $632. These time periods are in months. So that's what you've agreed to pay them, right? And your interest rate is in months as well. So I'm looking at R over M here, and it's 0.01. So in other words, I'm looking at the annual interest rate divided by 12, because this is all in monthly terms. Your actual interest rate is 12% annual. Oops, I didn't catch it to copy it. Here, hopefully this will work. Okay, so 1%. Notice how I've kept everything. The time periods are in months. So I'm going to write this time in months. The cash flow is the cash flow per month. This is my interest rate per month. And then I'm just going to compute the present value. All right, so the present value is equal to PV, the interest rate, divided, or sorry, not divided, then your comma, and then you put in your number of periods. And actually I'm on the wrong line here. You need to go up to time period 1. And it's already filled in here, but I'll do it for you again. The interest rate is 1%, and that's per month. Number of periods that first cash flow is brought back to time period 0 is 1 month. So this is that number of periods, remember, is N times M. Well, N here is 1/12 of a year, and M is 12. So when you take 1/12 times 12, that would be the exponent on your first term of your present value calculation. And that is 1/12 times 12 is 1. And so your time period is 1. Then we're going to have no payment here. Even though we do have a payment, we're going to treat each one of these payments as a single future value lump sum. All right. And so we get our present value for each one of these payments when we copy it all the way down. And this is what the bank is looking at. And think about this. The bank is trading you. They are going to receive these $632 payments over the next 48 months, right? They are going to have to, when you sum all these present values up, they're giving you out almost $24,000 today in return, they're getting $632 a month. So there's this trade-off going on. So this finance company pays out a lump sum, present value, and you pay them $632 per month for 48 months, right? And so we got the same answer either way. So remember, the easy way was equal PV, interest rate was 1% a month, 48 months, minus $632, no future value, and type 0. And you get the same exact answer. Any questions? I guess that's a big
good.
no. Everybody got that? Alvin's good. Is everybody else good?
Yes, ma'am.
All right, good, good. All right, so you see this on the PowerPoint. There's this equation. This equation, if I put it into general terms, comes from back over here. And that, if I were doing this on the whiteboard, I would actually be doing 48 separate present value calculations, starting with this very first $632 payment that comes in 1 month. So I would have 48 present value calculations. Turns out that if you did some algebra, you could put my big long 48 term equation into this one equation, which might seem a little weird because it says present value equals the present value of an annuity is equal to C is actually the payment. You'll see that term C several times, and it's because we'll use this again with bonds, and they call them coupon payments. Hence the C is a coupon. Well, your coupon here is the payment. So you can think of that as PMT as well. And then you just take brackets, and the numerator is 1 minus 1 over 1 plus your annual interest rate. Or you should actually put your periodic interest rate in there, raised to the number of time periods, which is N times M in our language, all divided by R over M. And so that is a by hand method that you could actually compute the present value of an annuity. And if we were doing this by hand using that equation, I would put in equal, and the payment is $632. And I'm going to multiply that times, all right, and then I'm going to put 2 parentheses in here to be careful. 1 minus another parentheses, 1 divided by another parentheses is 1 plus 0.01, all raised, and this is to that very first, there's 48 time periods here. Oops, I gotta go a caret and then 48. And then I think I've got, all right, 1, and then I can divide it by 0.01, which is the interest rate. I think I got that right. Oh, of course not. I probably have too many parentheses somewhere.
I think there's an underscore somewhere.
Oh, there it is. That should have been a minus sign, or sorry, plus sign. A plus 0.08. And then, and this is hard to do, not making a mistake, a really hard thing to do, to get the number of parentheses in there. And I think I've screwed it up. I think I have it in the, they've done it here. Oh, here, much better. Whenever this is the way you would put it in. And I wouldn't do this one in Excel at all, as far as like try to type that formula in. I just put it in a regular calculator. But there's a lot. It's very easy to make mistakes if you use that formula. And it's just, you saw me do it. How many parentheses do I need? And so it's just much easier to do it in the Excel function instead. I don't use this formula very often at all. And the reason is I'll tend to use the drawn out formula where there's 48 present values. And the main reason is because then we can talk about intuition. Intuition about, for instance, the interest rate. This formula right here, if I told you the interest rate were to go up, what happens to the present value? Well, it gets real confusing looking at this formula because the interest rate's in two spots. It's in the numerator, which is in a denominator, and you can't really see very easily that when interest rates go up, present value goes down, right? So that's why I don't use this formula very much. So if you ever were caught without Excel or caught without a calculator, this formula would be very useful to get the same answer, the $24,000 number, but I never personally use it. In fact, I don't even have it memorized because it's just not intuitive to me, and it's also something in which I would never do it just because I do it in Excel. Any questions about that? There's actually, you notice here, two separate formulas. One is a formula for the future value of an annuity. It's the same thing. It's not, I don't think, intuitive to use it. It's not the way I would write it on the whiteboard if you could see the whiteboard, and it's a whole lot easier in Excel, right? But if you had been living 50 years ago, you might have been doing that by hand. All right, any questions about these two formulas? Okay, let's try more problems. Oh, this one's a good one. Suppose you win the Publishers House clearinghouse sweepstakes, and it's a $10 million sweepstakes. The money is paid out in equal annual installments of $333,333.33. This happens over 30 years. All right, so I see an annuity there. That is a 30-year annuity of $333 some odd dollars. If the appropriate discount rate is 5%, how much is the sweepstakes actually worth? So could anyone tell me what kind of problem this is? Future value problem, payment problem, future value, present value, what?
Present value.
It's a present value. All right, so we need to be prepared to win this lottery. So, you know, they always give you this choice. The choice, so they call it a $10 million sweepstakes. It's really not, though. So if you take $10 million and you just divide it by 30, you get that number, in which is their payments. $333,333.33. And so that $10 million sweepstakes it's really not worth $10 million. They're not going to give you a check for $10 million today. They're going to give you a choice. And the choice is going to be between this annuity and some lump sum value. The question is, what is that lump sum value? And the next question would be, should you take the lump sum or should you take the annuity? So since this is this is over 30 years, I'm going to have a timeline that is now going down to 30. Whoa, going down to 30. And note that I've changed now years. I'm not talking months in this column anymore. I'm talking years. Excel does not know that. All right. So Excel has no idea if that one is your first month, your first day, your first year. It has no idea. All right. My cash flows, I would be receiving $333,333 $333.33 at the end of every year for 30 years. All right, they're telling me that the appropriate discount rate is 5%. Okay, so we're not talking about, this is not a cash flow per month, this is a cash flow per year. And my interest rate per M is 1 here, so my annual interest rate, this is an annual interest rate, is 5%. So note that the payment, the time frame, and the interest rate are all in annual terms. Okay, so I'm going to go ahead and click on that very first cell, and you can see here my present value. I'm trying to figure out what is this lottery really worth, and my interest rate is going to be 5%, E4, I'm cell referencing. My number of payments, that first payment is 1 year out, so I'm clicking on the 1. I have no payment per se doing it like this. Instead, I have a single future value of $333,000. All right, so that very first payment is worth to me $317,460.31 today. I copy that formula down, and I get my present value for every single one of these payments, right? And then I add them up. And when I add them up, I get a number, $5,124,150.29. And so you are indifferent between taking this annuity that's going to give you an annual payment of $333,000 versus taking a lump sum today, $5,124,000. Right? You're indifferent between that if you're using a discount rate of 5%, right? Now, which one would you choose? So that $5 million sweepstakes is really not worth $5 million to you. It's worth, sorry, that $10 million sweepstakes is really worth $5,124,150. That's what it's really worth in present value terms with an interest rate of 5%. Now, to get that same number, we can do this the easy way, and we can hit equal present value, open up the parentheses. The interest rate is 5%. The number of periods here is we have 30 years worth of payments, and the payments are $333,333.33. There is no future value lump sum to take in consideration, and these are an ordinary annuity, so it's type 0. And I should get the exact same number, and I do. Now, what happens if you thought that you could actually do better than 5% interest? That your opportunity cost, let's say, was 10% interest. You thought you could get a 10% return over the next 30 years. Would you prefer to take a lump sum, or would you prefer, and when I say that, the lump sum you're being offered is $5,124,150.29. So that's one of your choices. Take that lump sum cash, or take the $333,333.33. It's all about what you think you can get in return. Now, that was based off of a 5% assumption on interest rates, right? So what if interest rates were actually 10% that you thought you could get? Which one would you pick? The lump sum 5.1 million or the annuity?
You would take the lump sum at the 5% that they give you and then take it and then invest it at the 10% and get that return.
Exactly. Right. So you would take the lump sum, right? You would take the lump sum, definitely. And if you did, so you're looking at it, and if they offer you 5,124,000, you understand that this is at a 5% interest rate, but let's say, oops, okay. Let's say that you can really get, whoops, 0.1 here. If you thought you could really get 10%, you think it's actually worth 3,120,000. And so you're definitely going to take that lump sum. If they offer you 5.1 million and you think you can actually get it invested 10%, well, that means that you really think that annuity is worth 3.1 million. So you're going to take that 5.1 hands down. Does that make sense to everybody? Take the cash and run. Now, we're not talking taxes here. So we're eliminating taxes here from our decision. And there's some serious tax implications that you would need to talk to an accountant for. All right, is everybody ready to win the lottery? Everybody know what to do? Okay, it really all depends upon that choice, you know, the lump sum versus the annuity. And you can actually back out, like if you told me that the lump sum, and I'll put this back at 5%. And I'm doing this the hard way with this big table here. But if you told me that my option was to take 5.1 million versus that annuity, I could actually back out what that rate was. I could figure out what the rate was that it's implied. And I know it was 30 years. The payment was 333,333.33. Present value was a lump sum of, let's see, 5 million. And I'm just going to click on that. And it had a negative sign, so I got to get rid of that. I could back out what they're implying the interest rate is. Does that make sense? What I just did was I just if I were only given the information that I got that annuity versus 5,124,000, then I could back out what the actual rate of return they were using to discount the annuity. And that gets me 5%. And then I could sit there and I could think about, oh, could I do better than that? And if I think I could do better than 5%, I would take the cash. And if I didn't think, like today, I don't think I could get 5% without taking a great deal of risk, given that the Federal Reserve Bank's just pinning interest rates down to 0. So right now we have really low interest rates, historically low interest rates. And I'm worried here that, you know, interest rates will go up, you know, to what we would call normal. And in today's environment, I would probably be inclined, if that discount rate that was being implied was 5%, I'd probably be inclined to take the annuity. Does that make sense to everybody? Because interest rates are so very low. All right, any questions? All right,
Not from me.
so we're ready to win. Not from you, Alvin. What about you, Terry? I can see your face. You good?
No, no questions.
No questions? All right, good deal. All right, here's one. Now we're buying a house. It's another real life problem. You're ready to buy a house. You've got $20,000 for a down payment. And that 20 grand has to go for not just the down payment, but also the closing costs. They estimate that your closing costs should be about 4% of the loan. Now, that's not 4% of the house value, that's 4% of the loan value that the bank's going to make to you. you have an annual salary of $36,000 a year, and the bank is willing to allow your mortgage payment to be equal to 28% of your monthly income. Okay, we've got some ciphering to do first of all. So let me get rid of this table, get us in a new table. So it looks like we've got a 30-year fixed rate loan, and it's going to be paid monthly though. All right, so I'm not dealing with just 30 years here. I'm going to be dealing with 360 months. So I need to change my timeline here to go all the way out to 360. So these are getting to be long timelines. All right, 360. And where do I get 360 from? That is 30 years times 12 months in a year. That's where we get that from. So there's going to be 360 months to pay this house off. All right, so going all the way. So this is a really long timeline. This will take up my whole whiteboard. Now we've got 20 grand though to put down. Let's talk about how much the bank is willing to set your payment at. The bank said that they are willing to pay you or let you pay 28% of your gross salary. So that's 28% of 36,000. Sorry, got one too many zeros in there. I need some commas to see everything. All right, so that is $36,000 per year. So I need to put this in monthly terms. I'm going to divide that by 12. So per month, the bank looks like that they're willing to provide you with a $840 payment. Does that make sense to everybody? So I just took 28% of 36,000. That gives you your annual amount that could be obligated to this mortgage, and I'm just dividing it by 12 to put it into monthly terms. All right, so they're willing to give a payment here. This is a monthly payment, and this is time in months, and your obligation is going to be $840 per month to that bank. And that's going to be for 30 years, which is 360 payments, going all the way down. So this bank is looking at an annuity. They're going to collect an annuity from you, $840 a month over 360 months. All right. All right. So now the interest rate that they were willing to give you was 0.5% per month. Well, 0.5% per month, just to give you an idea what the APR is. The APR is the annual percentage rate. That's going to be 0.5 times 12. They're really offering you 6% per year, right? So normally the bank is not going to tell you your periodic interest rate, like in this problem. They're going to tell you an APR, an annual percentage rate. And so you would be seeing an interest rate of 6% annually, right? Although your problem is giving it to you in 0.5% per month. All right, so your interest rate, I'm going to put in monthly terms. Monthly rate, 0.005. That is 0.5%. And that is fixed over all 360 months. This is a long loan. All right, we're to the bottom there. All right, the question is, how much is this bank going to actually lend to you? And do you have enough money for the down payment and all the closing costs? Well, I'm going to do this, find out how much the bank's willing to lend. They've told me the interest rate. I know the payment that we're going to be able to make. So we're just going to find the present value, which would be the loan value, which I'm going to, for the rate, my monthly rate's going to be that 0.5%. The number of periods is going to be, for that first, we're finding the present value of this annuity. And so this first period is a monthly term. The first period is the first month. There's no payment, and the future value is $840. So that very first payment of $840 is worth $835.82 today to the bank. I'm going to do that for all the payments, find their present values. And when I sum those up, that's going to be our loan value. And I just hit sum, and it was $140,000, $104.96. That's how much the bank is willing to lend. That amount. Okay, so we're going to have now some closing costs are the next thing we need to address. So the loan amount is going to be $140, $104.96. The closing cost, they tell us in the problem, is going to be 4% of that loan value. So I'm just going to take equal 0.04 times 140. So the bank's going to require $5,604.02 worth of closing costs, right? So just 4% of the loan value. So your $20,000 that you've saved up is going to be eaten up partially by that closing cost. The rest of it can be used for down payment, right? So how much the down payment is going to be? It's going to be what's remaining. So you got $20,000 in the bank. You're going to subtract from that your closing costs, and you're going to be able to put down $14,395.80. All right. So you take your down payment. This is the house value that you can actually go out and buy. House value is going to be the amount that the bank is willing to lend to you, plus then your equity. Oops, not your closing cost, your equity, which is the down payment that you bring to the table, right? So, does everybody understand what we just did? Any questions? Starting to get a little complicated here, but that's exactly how a loan for a home looks like. That's exactly the way it looks like. So the Federal Reserve Bank has lowered interest rates as of this week and last week. They've lowered some specific rates. The 10-year Treasury note has at one point hit something like 0.38%, which is extraordinary. That rate typically does not penetrate 1%. And we've been hanging around much lower interest rates than typically is normal. So what is the Federal Reserve Bank trying to do for homeowners? The 10-year rate's really important because mortgages are, their pricing is tied to the 10-year rate. So basically a bank takes the 10-year rate, adds on a risk premium for your interest rate. And so with that said, if the Fed lowers interest rates and you're like, for instance, 30-year rate, I can actually look up on the internet. Hopefully you guys can see this. You guys see me searching on the internet? Yes, okay, good deal. I'm going to add here mortgage rates. And I like Wells Fargo to go to. They're who I'm refinancing through. And I'm going to see a couple rates here, but here the 30-year fixed rate is at 3.5%. In our example right here, we just use 6%. So this is a much lower rate that's going today. If I look at Wells Fargo, so those were averages over the whole country, I think. Wells Fargo, they have lots of different rates, but here we've got a 30-year fix. That's a conventional 3.25%. This is a 30-year fixed rate for veterans. The Veterans Administration is also at 3.25%. Usually those mortgages for veterans they might be real close to the same rate, but they have lower down payment requirements. And so they're not, the 30-year fixed rate, typically you have to pay 20% down. It's pretty normal. And if you can't pay 20% down, you have to pay PMI, which is private mortgage insurance, which just makes your mortgage more expensive. So you can see here the various rates. You can see the 15-year fix is at 2.5%. All right, so based on that, if we go back to our little example here, if interest rates actually went down to what I'm looking at here, I'm going to put in here an interest rate of 0.0325%. Look like that's what it was at Wells Fargo, and I'm going to divide that by 12 because we got to put it in monthly terms for our spreadsheet. So you can see that our interest rate has gone down by half, almost half. And when I change that interest rate, what's going to happen to our present value when, in other words, the present value of the loan that Wells Fargo is likely to lend to us? Is it going to go up or is it going to go down? Up or down with lower interest rates? Up by a lot. Do you guys see that? So we changed the interest rate here from 6% APR down to 3.25% APR. And they went from about $140,000 loan that they would lend to you to a $193,000 loan. That's a big jump. It means that, so you can understand why the Federal Reserve Bank is lowering interest rates. It's because what that does is it entices banks with lower interest rates to lend more. So that's what they're trying to do, is to get financial institutions to lend more. And that will hopefully prop up the real estate values. And in fact, it props up just about any asset value. Right? Any questions about that? You want to do this the easier way? And the easy way to actually come up with this number, and let me put our interest rate back to what it was in our original problem, 0.005. Okay, so I'm reproducing that $140,000 number. That is just equal to present value. Interest rate is 0.005. That's a monthly interest rate. The number of periods is 360. And actually what I can do is even put this in, the math in straight into the equation. So I can put 6% divided by 12. Then I can put in the number of periods is 30 years times 12. The payment, I calculated to be $840. So I'm going to put in a minus 840. I have no future value because there's no balloon at the end that I still owe principal. And the type is ordinary. All mortgages are ordinary annuities. And there I reproduce that number that I did in this table right there. So that's a super easy way to do it. But I just want you to know that you can do it either way. So if you ever have a question about how Excel's reading something as far as the payments go, you can either do it the quick way, but sometimes you don't necessarily, especially when you're new at this, don't necessarily know how Excel really reads it. So I like to set up these tables so that you, even if they're really long, you have you've got confidence in knowing how these things are actually, they're just computing the present value for each one of these cash flows, and there's happens to be 360 of them to do. So it's a long table, but you just add up each one of the present values and you'll get the same answer. Probably takes a little longer, but you can do it either way. All right, any questions? All right. Clear as mud? All right, let's see. And you want to know how much was borrowed. Do you compute a present value or a future value? So if you know what the payment was, should we get in there and compute a present value or a future value? What have we been doing?
Value, right?
What's that?
It'd be present value, right? Because the future value would be 0, right?
Yeah, well, the future value, you can value this annuity anywhere you want, okay? But typically whenever we're dealing with loans, it's this trade-off. It's a trade-off between what the bank is providing you, in this case is $140,000, and you're going to provide them with an annuity, right? And so there is this trade-off, a lump sum today for the promise of all these payments in the future, right? So now I don't think, are you guys the ones that I got, I don't think we did this in class right before we left, but if you go to YouTube, you guys have probably seen this commercial. I think it's called J.G. Wentworth commercial.
877 cash
Everybody
now.
seen this one? Yeah, so I'm going to play that, and let's do this guy. I think I like the opera singers the best.
For sure.
I have a structured settlement and I need cash now. Call J.G. Wentworth, 877 cash now. I have an annuity, but I need cash now. Call J.G. Wentworth, 877 cash now. 877 cash now. They help now, they'll help you too. One lump sum of cash they will pay to you. Get long-term payments, but you need cash now. Call J.G. Wentworth, 877 cash now. 877 cash now. 877 cash now. 877 cash now.
So that commercial is all about what we did today. We're trading a lump sum for an annuity. And that's what J.G. Wentworth does all day long. And it's all contingent on that interest rate. That's the conversion between the two. That's the exchange rate between the two. All right, I think the class is over, right? Yep, 3 minutes over. You got your money's worth. All right, hopefully we can get this video thing straightened out, and I'll see you guys Tuesday. Keep doing problems, work more and more problems out of Connect. And if you have any questions for problems, send them to me via email and I'll try to get them worked in class. See you later. Peace out. Be safe.
So as soon as I stop recording, it'll start converting?
Yes, immediately.
Okay.
So when you hit the pause or, yeah. Is it started to do it?